think we can slowly get started, right?
Yeah, go for it.
Great. For today, this meeting is being recorded. Shaheen is being so kind. If you guys are watching this recording, please, join this Cartesi developer community, the Discord. We are having these calls on a monthly basis, with some updates from the ecosystem, with some, interesting guest speakers. Today we have Ronan here. I'll share the agenda in a bit. And just some interesting talks from the builders in the ecosystem overall. A short update on the Discord. As you might have, noticed, we are, we have now opened up the Discord. All the units are now on the Discord, so all the conversations are happening, in a visible manner online. So you're closer than ever to the community. We're closer than ever to the community, and we want everyone to engage, with us, with everyone within the community. If you have questions and stuff like that, we're here for that. We will also be in Paris for ETH Global from the July 21st to 23rd for the hackathon. If anyone is around, please, join us. You can also hack on the Cartesi track and win some prizes, but also just let us know if you're around. Would be great to meet up. For anyone new here, or sorry, as a reminder for everyone who's not new, just a little intro on Cartesi and why it's an interesting fit for on-chain games. First, you have app-specific rollups, which means your application can, tap into the full power of a CPU. You can build more complex applications, more computationally intensive applications. This is perfect for on-chain games. As you can imagine, you can run a Cartesi rollup on top of an Ethereum or on top of the EVM of your choice, such as Optimism as a layer 3. So that's really up to you as a developer. And second of all, you have this really expressive general purpose execution environment, virtual machine, meaning you can run, traditional software, basically software stacks directly on top of the Cartesi machine, as long as it compiles to RISC-V. And Linux really unlocks, all these libraries, these languages, etc. So you can build more complex applications, more complex on-chain games, but also tap into a lot of content and abstractions that exist already and that are continuously being developed in the open source world. So let's get to the agenda. Today we will have some short, project updates. In the last call, we went into some deeper presentations from the builders, from Ultrachess, Dazzle. In particular, today we just will have a couple minutes to update these projects, or to give some updates on the projects. Then we will get into our special guest speaker, Ronan. Thank you so much for joining. And finally, we want to have some discussions around on-chain game frameworks. I will also, share a small presentation around that, and then we can really enter some conversations here to better understand what's happening in the on-chain game world, understand what value Cartesi can provide, and what kind of frameworks might be useful for the builders in the ecosystem. All right, so let's start with the project updates. Let's start with Ultrachess. Jesse, the floor is yours.
Hello. Yeah, so nothing really new to update yet, but basically Ultrachess is an on-chain AI chess arena. It allows people to deploy bots on-chain and battle them against each other for money. So here's some footage. Right now, I'm challenging this bot with another bot. So you're gonna see it receive a challenge in the bottom screen in just a moment. Yeah, so the person I just challenged, he received the challenge, and now he's accepting the challenge. Right. So he accepted the challenge, and now his bot just battled my bot for about $69. And now we're gonna check out the results of that battle. Now it's playing. And in this scenario, my bot is the one at the top, and the opponent's is the one at the bottom. So we already actually know what happened. My bot lost, but we're just gonna play it through and see how my bot lost.
So on the right side, you can see the moves, right?
Could you repeat that?
On the right side, under the right side area, is that like those are the moves, right? From the different bots.
Yeah, that's the move history, yeah.
So for anyone who
Checkmate.
checkmate. Very cool.
Yep.
Nice. So yeah, just to add a bit to this, please follow Ultrachess.org on Twitter if you haven't yet. Jesse, is this already ready for testing or soon? Do you want people to start joining the Discord? Or is that something you'll share on the Twitter a bit later down the line?
Yeah, I'll share it later.
Okay, awesome. So make sure to follow the Twitter to stay up to date. Really pumped about Ultrachess. You know, given the Cartesi machine, the RISC-V, a VM, you can really deploy, UCI compliant bots, and that includes, AlphaZero, DLA, etc. Have them battle each other, trade the bots, place wagers, etc. And yeah, just a super cool use case, and really excited about Ultrachess. Cool, thanks, blockchain. Let's get to the next one. Teddy, you want to give a bit of an update and short intro on Ethereum for the new joiners?
Yeah, sure. So Dazzle is a 3 versus 3 puzzle fighting game that lets you pick three of your NFTs against 3 NFTs of your opponent. So it marries Web2 components like free-to-play model that lets new players to easily join and play. But of course, for anything serious, it's running on Cartesi rollups, which runs all the logic on chain and make sure that everything is secure. So right now we're at the phase where we've been doing a lot of polishing. We've been adding a new mode for a PvE experience, and right now we've been recently opening up our Discord for people to join in on the development, and soon we'll be opening up for testing. And for those involved in testing, we plan to hopefully be able to give some goodies in the future.
Fantastic. Thank you, Teddy. Yeah, really pumped about Dazzle. If anyone here has questions about these two games, feel free to drop them in the chat or raise your hand. Definitely also excited, super excited about Dazzle. You know, it feels like a Web 2 kind of game, but it's fully on-chain, fully verifiable. Yeah, I'm just excited to see what you guys think, and once you guys get testing. So definitely join the Discord, and let's get going. Thanks, Teddy.
Thanks.
All right, if there are no questions, I don't see any hands raised. Let's move on to Ronan. So just to give a short update or intro to Ronan, you know, with his company Etherplay, he's been sort of exploring the intersection of blockchain and gaming from very early on, already starting in 2016. You know, he's the creator of conquest.eth, one of the earliest on-chain games. You know, as an infinite game or on-chain game pioneer, it's really a pleasure to have you today, Ronan. Feel free to unmute yourself. Thank you so much for joining.
Yeah, thank you for the intro. It's really cool, like the two demo. Like, I mean, it's really cool to see. I think it's interesting how there is different community in the on-chain game space, really, and you know, so it's kind of each his own bubble, it seems sometimes. So it's cool to see, because I heard about Ultrachess before. You mentioned it to me actually before, and it's cool to see how it look like already, you know, ready to be played. It's really cool. And yeah, I don't have any preparation for this call, so I don't know if you have a specific thing we want to discuss, or any like agenda on your end. But happy to go in any direction, really.
No, that's awesome. No worries about the presentation. But maybe, you know, we can sort of have like a bit of a Q&A of sorts, because, you know, you have a lot of, you know, you probably have a lot of learnings, and you've been in the space for so long. You know, I'm curious, maybe first of all, kind of what led you to this idea of infinite games?
So, I see, that's interesting, because it was kind of the first thought, even though the thinking was not, you know, really established or like thought much, but that was what, when I learned about Ethereum, was I actually, before Ethereum, I'm a game dev as a background, but I was always interested in peer-to-peer networks. I remember playing with, I forgot the name, there was a Java framework where you could build like protocols, peer-to-peer protocol. And, you know, there was people, obviously some game were already peer-to-peer, you know, like even LAN type of game where, but still there is this element of trust basically on this thing. So you couldn't scale it to players that maybe didn't want to screw your game or whatever. And so when I discovered Ethereum, was like this idea of like what we can build basically serverless games. And so it means, and on top of that, because the network have something to keep it sustained, you could have this running forever. But I didn't really thought much, but I remember talking with other developers that like we were talking about, oh, what if we build a Dungeon and Dragon thing, you know, using like, I don't think we mentioned the word NFT, it was not there yet or anything, but then I realized also the limitation. And so my first experiment actually on Ethereum was using something that would have benefited from Cartesi actually. And I remember that's how I learned Cartesi in the first place. It basically was an arcade machine where you play the game as a single player and then you post your proof on chain. And because it was not using Cartesi, it was basically relying, it was kind of cool because it was verifiable. So, but as a company, we were the one deciding who was winning. but everybody could see whether we were cheating or not. So that was, I think, kind of the selling point of our project. But then the gas fee started to rise, and then I started to explore other kind of idea, and yeah, that's kind of how I started really.
Love it, love it. So you built conquest.eth. Can you kind of share your challenges and your learnings from that, and how you kind of got to that first?
Yeah,
Is that
so that was
not
interesting. Sorry?
That wasn't your first game, right? Because you mentioned the arcade idea, but conquest.eth
Yeah.
was like, yeah.
Yeah, there was a few games actually. Yeah, I think it's good to go back to where I come from, because so actually when I kind of started to look at other ideas, I kind of posed the idea of having the fully thing like on chain at that point. You know, it was only Ethereum mainnet at that point, and so it was quite expensive. But still, I wanted to explore. So we participated in a hackathon actually, like in 2018. We were kind of disappointed because we didn't won. We had the only game that was actually running. The other had just a presentation, and they won the game category. So I remember being upset about that. But it was a game called Tug of War. It was a very simple game, two-player game, a bit like a complex rock, paper, scissors. And there was a lot of work on the UI. I think this is a common thing in on-chain games. Like the most difficult thing is always the front end. And it was working, but we never released it on mainnet. It was on a testnet, but I played with few people. But because it was not on chain, I think I never had a real match to the end, but because there was no money at stake, and so people were joining, but then they were it was like you had to play one time every day. That's how it was working. I mean, there was different setup actually, but yeah. So it didn't really. I realized that I cannot launch it on mainnet. We will play, with this gas fee, and then at that point, I think I did look at different design where the blockchain was not so important. But then back, I think in 2019, beginning of 2019, I realized that okay, I think that was a time where there was things like XDAI. Polygon get started or something, and I was realizing, okay, fine. We can see the trajectory. We know that we are going to be able to make game on chain. Maybe they are not going to be fully decentralized because the networks themselves are not. But we are at the beginning, and you can project yourself and see that okay, fine. We will reach a point where we can really run this thing with a kind of a low gas fee, and so I realized let's build now, and so I started with Eternal, which was like back to the idea of a Dungeon Dragon kind of thing, but without the Dungeon and Dragon rules because there was no point to use them. So it was kind of a dungeon of exploration. Like the first prototype actually was based on the mud games, where it's just text based and you move. Actually even this mud have a map. So in the first version of Eternal, the one we showcase in DevCon 5 in Japan, and then we had like a demo where people were moving around, and it was only text based, a bit like Zor, a game like where you have text and you decide what to do. But then quickly we realized people want a map. And so we kind of build the map, and it become like a far nicer experience as well. But I think we spent a lot of time kind of discussing what it should be rather than, so we went to many different directions, and at that point we abandoned the game at some point. But during that time I was also thinking, what if we designed something very simple? And I had a favorite game of mine called Conquest with a K that I discovered with Linux. So it's like on the KDE. If you know KDE, you probably know this game Conquest, which was one of the game that's part of the collection of game on this desktop environment. And it's a very cool game when you play at least 3 players, because there is this backstabbing required to win. And I realized that what if I make this on the blockchain? And the main learning is, the main thing for me is that you don't put something on a blockchain just for the sake of it. You have to think about what does it mean, what can you use it. And so for me was in many games you have an issue, like if you put money at stake, which is why I think it become interesting suddenly to have on-chain, but you also introduce several issues. So one of them is like, let's say there is only a fixed number of players in Conquest, which is how the original game was. Then suddenly you can't play with money unless you know who is playing and you know that they are not going to collude against you. Like, or at least it's fine that they collude as part of the game, but not if they already pre-established to collude against you, because then obviously you are going to lose. And so there is no point playing, and then you lose. So you have this issue as, it's interesting, like two-player game don't have this issue. Like, it's completely fine to have them on-chain with waging money, like Ultrachess, no problem. But as long, imagine you have a chess of 3 players and you have these 3 bots, suddenly, if they pre-establish to collude, then the third one is kind of no way to win. And so the solution for Conquest was, let's make anyone join at any time. And so that's, I think for me the interesting thing about Conquest is that it worked. It's really, people enjoy this aspect of like, okay, I mean, to some extent I say it worked, but I think it was not tested enough, in the sense that there was not enough money at stake. I mean, the maximum it got was, I think, around $2,000 at stake at the peak. And I don't think it was enough to establish whether, the design made sense. Like, but it was still interesting to see all the player playing with that money at stake. And I don't know if you have other specific question. Maybe I'm going everywhere.
No, you're not. I think it's super interesting. By the way, anyone who has questions, please drop them in the chat. Anyone on stage, feel free to unmute yourself and ask questions directly if you want to. But I think that's really interesting. Ronan, what were like, beyond like the 3-player issue, what were like kind of challenges that you faced back then with Conquest that you'd like to see resolved in the future, or maybe are already being resolved nowadays?
So I mean, yeah, there is few things on the. So I've been rewriting actually the whole thing, my tooling, everything, the last year almost. And one of the things that I mean, it's kind of specific to Ethereum to some extent, but it's like the issue of fetching data from the network. So in the first alpha of Conquest, I was just fetching every planet from RPC call, and it was working. So when you were moving on the map, it was loading as you were, like as was fetching more planets, and it was obviously batching the call. But it was not the best experience, and I still had to access to events as well to know what was happening for the player. But the cool thing, and that's why I did that way, is that the first alpha had 0 backend. Like, there was no backend required to play the game. There was a backend, an optional backend used to sync your data across device, like encrypted, and it's something I plan to keep, but it's just optional. Like you as a player, if this go down, or it's fine. And it's also designed, to make sure that it can't even you can delete the data from your server, but it cannot. There was a kind of interesting algorithm here to make sure that you cannot lose data by having a malevolent backend. I like to design system like that. If I have to sacrifice centralization, I want to make sure that the client is still king. But the issue was like this kind of user experience thing. So I kind of, for the beta, I used the graph to index the data. And so this way the fetching things were a lot more efficient. But the issue was the maintenance. I'm working on this as a solo developer, and I think it's a good thing in some respect, because you have to keep everything at low maintenance. You have to make sure, and I think it fits very well with this idea of decentralized game, because when you make a game, you don't want to have anything that players are dependent on. And so I had this dependency on the graph, and so I had to run my own graph node, because sometimes the hosted service was down. And it happened that one day both of these things were down, both mine and the graph. And for 2 hours, I think player couldn't play. And we are talking about games that have money at stake. And so losing 2 hours, it can be like fatal. And so then I realized, yeah, I need to kind of work on maybe alternative solution. I mean, it's definitely feasible, to maintain a graph node, etc. But I could see that we could make it lower. There was also a lot of things popping. There was also a lot of people now looking at other EVM chains, and I was thinking, yeah, it makes sense for Conquest to be on multiple. But I was not feeling confident to do that if I had to maintain again another graph for each of these. And so I started to look at building my own indexer, but this time running in the client. And actually, I got it working. So it's now I got a grant from 0xSpark for that, and it's working. It's just now not being used in production yet. But the plan is to actually release Conquest v2 with that. So it's more on the technical side here. Otherwise, I think. Maybe more, I don't know. I'm not sure what we are missing. I feel like everything is there. It's just a matter of I think the tricky part of on-chain game is mostly design, like game design, rather than anything else. But yeah.
I feel that. I think, yeah, no, I was kind of trying to lead into the conversation later about on-chain game frameworks. I know you've had some experience with MUD and a few maybe other frameworks already, or you've looked into it, but we can get to that conversation in a bit. I see there was one question in the comments from Mazouk here. So he says, you've mentioned your background in game development. Given this experience, how do you envision the gaming community transitioning to Web3 more effectively and truly grasping the benefits it can offer? It's a tricky one.
Yeah, I don't know. I think, so for me, I see, I don't come from the AAA game dev. I come from casual games. That's kind of my professional experience was in. And it's something I never really felt that much interested. Actually, to be fair, there was some interesting thing. I remember the community there, which kind of is somehow reminiscent of Web3 communities. Like, we were making updates every 2 weeks, and sometimes we were making a new features or changing something, and then you would have the community shouting at us on the forum, like, why did you change this, or things like that. And it's very reminiscent to me of some of the Web3 community, but of course without the kind of maybe the other side of it. But so I just wanted to give the background because I think there is different people, different things. But I think what interests me also in the game industry was always the indie games, which explore different game design. And I think this is probably the community that will succeed to do something different. That will, I mean, I'm not talking about success, because in crypto you can have success without actual success. In my definition of success, you can have something that make lots of money, but at the end of the day doesn't really do anything that was not there before. But I think the indie dev, maybe, I think they will be the one who harness the power of blockchain to do games that was not possible before. That's how I see. I don't know if I answer your question, but
no, 100%. I think that makes a lot of sense. Kind of the indie devs. I guess there's also the component of how do you get players to join Web3, and that's a whole other topic, right? With
yes,
layers.
Yeah, it's true. I think it's something I didn't focus on, and it's something when I think about it, it's always tricky because on-chain game for me rely on this monetary value or this value that you have to lose and yeah, there is a real cost to join this game. And I think to me they increase immersion, so I think that's the benefit for players, but it also means it's harder for them to get into.
Yeah. Vitalik himself was a WoW player, right? And he says that he got really pissed when his character was nerfed, and he didn't agree with that. But that's another thing that
cannot be stressed enough that with Web3 gaming, you have a say, right? And you have options. It's not like the developer does whatever he wants, and you just have to comply with it.
Yeah, definitely. Yeah, and I think it's also part of the community is usually, I mean, the open source component to usually associated with smart contract, I think is crucial, and I think helps this because it helps. I think okay, we don't like what you do. Maybe it's still like people could have like some people I know in the blockchain community. There is kind of a big divide of should we have a game that gets updated with a DAO, or should we have a game that cannot be updated? There is a divide here in the community, but as long as the code is open source, at the end of the day, like people even with a DAO could say, you know what, we are going to rebuild our own version. And yeah, to me, I'm more in the side of like a game that cannot change, and then the way you change is like through forking basically, and so basically why open source is important, or at least is important, and also that's why that's another interesting topic about how can you help forking, because this is really the key decentralized component actually of blockchain in general.
Yeah, super interesting. So sort of evolution through forking. Versus like evolution through sort of composability within the game, kind of.
Yeah.
Milton asked the question, would you have a pointer to the indexer you are building with OXPark that runs on the client?
Yeah, I can share the link. Actually, the package name is the npm package is called Ethereum -indexer. I managed to get the name. This is the GitHub repo. So it has limitation because it runs on the client, and so. But so, for example, don't expect to index all the NFT. But you can. It's interesting because it runs on the client, you have interesting capability. For example, instead of indexing all NFT, you can say, "Oh, just index my NFT," and this is something, of course, doesn't make sense on the server. Like, you will not index only someone NFT, but on the client, suddenly it makes sense, and you can do that. Like I tested with Vitalik's NFT, and it took I think it took 1 minute or maybe 2 minutes to index on mainnet using the indexer, and then obviously you can cache. So it's pretty cool.
Awesome. So I'm curious, maybe Ronan, maybe you can talk a bit, because I know you have a lot of projects. On top of Conquest, you also have other on-chain game projects, but even like I think you have a on-chain music project. Was wondering if you want to touch on some of those.
Yeah, it's true. I have too many. I used to think I have too many, I need to stop. Now I am like, I have too many. Okay, why? It's fine. I'll add more. So I have actually two. So this was an NFT project. I have two NFT projects. One is called Mandalas. I think it's the first bitmap on chain, I think, and the Blips is the first wave file on chain, basically. So the idea is that the whole thing is generated in Solidity, and like for Blips, it's like basically an oscillator implemented in Solidity. So Solidity output a wave file, because lots of they call on-chain music project are usually not that on-chain. They are going to be like having the data on-chain, but then you have a player that runs in the browser that produces the sound. In the case of Blips, it's like the actual wave file is generated from the it's sending the link here, but and I didn't finish actually the project. So the first part was this individual sound, and then after you can compose them to make a music. And obviously it's very limiting because you need to run the full thing need to run in the 50 million gas limit, which used to be 30 million, because you have kind of a different limit in gas by default. So I assume, and now it's 50 million, which is the amount of gas a call can make when you read data. And so this can generate like maybe, I don't know, 16 seconds of a music. So you can make small music with it. Yeah, I mean, for me, that kind of this project was our hackathon project where I kind of like, okay, what can I do with Solidity that will be fun? And then I realized, oh, we can add stuff. So Blips DAO is also a DAO, which it was inspired by Nonce DAO. And so the idea is that when you own a Blips, then the music created using these Blips can give you a royalty. And that part is not yet implemented. And I feel a bit sad. I keep telling myself I'm going to finish it, and I really want to do it, but it's just a matter of like finding the time. But yeah, apart from that, I've also worked a few working project games. One of them actually is using Cartesi. It's very reminiscent of what Ultrachess is doing, and I can see some potential like framework there where, to matching people, all this stuff that is common for this game. But it's basically a robot battle game, except like using physics and robot playing in a physical world. But I didn't do any implementation yet. So really keen to actually explore Ultrachess further. Other games is like a ZK game inspired by a card game, so a 2-player game. I think it's a good example for what ZK can do, because I see a lot of mention of Battleship, and Battleship I think is a not very good example, because if you think about it, Battleship is actually mostly a single player game, because the person setting up these ships that cannot change them, then it's a matter of just iterative game, and that's why it's kind of a good example for ZK, but at the same time it's not that good, because the benefit you get as a game, I think, is not really good. So the game I was exploring is interesting. So it's based on a card game which have very interesting mechanics, and that fit well. Actually, I have a link to the source code as well, and send that. And the other game, two other game, but too many. Like one is Stratagem, a game that come from a lot of learning from Conquest. So I guess it go back to what you were asking before, but I think what I would like to explore for Conquest. So Conquest was designed to be gas efficient. The way things work is like it takes days for spaceship to arrive. The real days. The idea was like, okay, you don't need that many transactions, but in practice, people are micro-optimizing, and so it's still relatively gas heavy. I mean, still low, but still not enough for L2s, for example. And so I was exploring this abstract game. It's a bit like, the idea was to make a game of Go at the beginning, game of Go on chain, and make it multiplayer, and then it became its own game because Go couldn't work. I'm really keen to have that deploy at some point as an MVP. Right now I've been working a lot of my tooling, but I think after summer I should be able to focus on games. And so this is Stratagem, and another one I joined the hackathon, the Autonomous World Hackathon, and I made a dungeon game, which again, it was inspired from the issue I had with Eternal, the game I mentioned before, and kind of try to minimize the gas. So that's kind of but I don't know if you have a specific question about them.
No, man, I love it. You're doing a lot of cool things. So how was the hackathon, Autonomous Worlds hackathon? Did you use MUD in the end, or?
No, actually, I didn't use MUD. I really want to look at it. I've read about it at a high level, but I was at that point. I was like, okay, I need to test. I'm still working on my tool, and I was like, okay, no, I need to test. That's a perfect opportunity to test out the tool, the tech stack I have, and so I decided to keep doing with my own stuff. So I actually made a Twitch stream. I didn't edit it yet, so I think it's probably not that easy to watch. But if you can skip some of the thing, you can look at my development experience for the hackathon. And I mentioned, so I describe a bit the tech stack and the game. So yeah, I can maybe give the link to the Twitch stream. It's just my Wigawa handle, but. And I don't know if I'll continue doing Twitch like that. It was the first time. I think it's good for me if I want to explain the tools I'm using. But yeah, so for the hackathon, I didn't use Mud. But yeah, maybe another time.
No, awesome. Yeah, I think that's kind of the next topics. We'll cover a bit of Mud, or at least game frameworks. But first, curious if anyone else has questions, or Ronan, if you have questions as well to people in the chat, or to Ultrachess, Dazzle, etc.
I mean, yeah, I will be interested to know, like, how Ultrachess is thinking about other game. Like, how does it already have some kind of framework for matchmaking and stuff like that? Or I'm really interested in, also, is it open source? Because yeah, like I mentioned, I was this game idea, and if I could reuse some of the thing already done, that would be great.
Yeah, I mean, blockchain. You want to jump back on stage? Oh, I see you. Invite sent. Let's see. But yeah, in the meantime, I know. Oh, there he is. Blockchain.
Oh yeah, it's open source right now.
Oh, it's already open source. Cool.
Blockchain. You want to talk about the fighter game as well?
Oh yeah, and then there's another project called Cento, and it's basically the same exact thing as Ultrachess, but with fighting game characters. So on-chain fighting game characters.
Nice.
Where they're
So like,
AI logic.
Is it like Tekken or whatever game, like 2D, like whatever? I should use.
Yeah, it's more like Street Fighter.
Yeah, Street Fighter.
But their logic is on chain, as well as their pixel data and their animation data. Everything is on chain.
Cool. Nice.
Yeah.
And do you have like a framework for this matchmaking, all the things that are basically not on chain and that is required to have a nice user experience?
So the matchmaking itself is also on chain, so it's within the Cartesi machine.
Okay, cool. Oh yeah, okay. Okay, so is it something you can reuse across like game, I guess?
Reusability, like in terms of the matchmaking system, it's proprietary to Ultrachess, and like it's for the app itself, since it's all within the same machine.
Okay.
Cool. Well, yeah, you guys should definitely have a chat, connect. Maybe there's some overlap, synergies. And yeah, feel free to drop them in the chat. I see Milton is typing. And yeah, the next topic will be, oh, here, Milton. Could you reuse a software as in importing the source for another game? Blockchain, I think that one is for you.
Oh yeah, you could copy and paste some of the code. A lot of it is reusable and can apply to other things. Cento and Ultrachess share a lot of the same source code. It's just I replaced the bot stuff with different stuff, but for the most part, they have the same exact code.
And maybe can check these common parts and extract the framework out of it.
Oh yeah, that's very possible, yeah.
Yeah, that would be sick. Awesome. Then I think let's move on to some discussions around on-chain game frameworks. So why do we want to discuss this, or why is this interesting? So we've been discussing on-chain game frameworks internally. Some of you and I and Carlo and everyone had some conversations, but it's good to also do these conversations, I think, in these open community calls and really understand the needs of builders and the wants, etc. And you know, the goal would be to eventually understand what would be a good fit for Cartesi. I think something like what Ronan and Blockchain just and Milton, for example, could be something interesting and could be something reusable, but there might be other things as well. So really curious to hear about, that's right, Ronan also asked you a bit about your hurdles as the builder and essentially what would make your life easier in the future, right? Before we open up kind of the conversation, I wanted to highlight some of the frameworks that have been developed across the ecosystem. So also outside of the Cartesi sphere, right? And lately we've seen quite a lot of projects, frameworks, tools kind of popping up and basically striving to make it easier to build on-chain games. And there's a lot of overlap with some of the discussions we've had in the past around these topics, such as horizontal scaling. And it's really good to see some of these concepts getting more attention. And I think overall the main point here is for Cartesi to lean into its strengths, right? With its custom, highly expressive VM. There's a lot of things you can't do, outside of that or without using Cartesi. So yeah, just curious, and I think the main point here is to first kind of dive into some of these frameworks from a very high level perspective. I'm not super technical. I hope Carlo and the other speakers or anyone in the audience can complement and help sort of enrich this discussion. But I will start by sharing a bit on the on-chain game frameworks that have been popping up and that I've been following a bit. So to start, I try to so these are kind of the main ones that exist today. You have Mud, which most of you guys are familiar with probably, and that we just discussed a bit. Dojo, which is Starkware's version of Mud in a way, if I'm allowed to say that, World Engine from Argus Labs is another framework. I've been sharing some of this stuff on Discord as well, so some of you might have seen this already. And finally, we have Keystone by Curio. Keystone runs on top of, has a custom OP chain and World Engine. I'm not too sure, but they have kind of this EVM based shard with some shards on top, but we get to that in a second. First, a few patterns that I've noticed. We have stuff like dev tooling with Foundry dev tools, no need to write your own indexer, some of the parallels that we just heard Ronan talk about, client-side data stores. We have, in some cases, the desire for more expressiveness. Two of the frameworks actually let you write game logic in Go. And finally, we have scaling and sharding, which we mentioned with potentially parallelization or a game shard horizontal scaling approach. And finally, a lot of these frameworks have this entity component system in common, which is really, wants to make it easier to compose, have composability, add on features, etc. And it's also potentially a familiar environment for developers, as this seems to be, a framework that exists in the traditional space and that people are used to. To get started, I just wanted to highlight this little clip.
Here's a long segue into the software engineering instruction ladder. So usually you have instruction sets or virtual machines. That's the interface with the hardware, things like RISC-V. That's like for traditional computing, RISC-V or like x86. And you have programming languages that compile to that instruction set, and then you have frameworks that run in those programming languages, right? For Ethereum, we have a single VM with programming languages, Solidity, but we have no framework, right? And I think it's really surprising that we haven't seen something like this yet. And my intuition is that it wasn't really needed so far. Actually, it wasn't needed for the first 2-3 years, but then we got into this weird loop where nobody thought we needed a framework. So nobody built one, and people kept building the things that you could do without a framework. And then now people are reinventing the same application 100 times in a row. There's this crazy triple jerk of like, oh, we're going to make this thing faster, and we're going to code goes that thing. And I think it's really, really regressive. And so the other thing that is very surprising is because we don't have a framework, the people building Ethereum, they're putting things that should be in the framework in the actual language or the VM itself. Like things like ABI.encode shouldn't be in Solidity. Like this just doesn't make sense that it's baked in the language itself. Off-call, account abstraction, like all of those things, like even the timer opcode shouldn't have to be in the VM itself. That should be exposed at the framework level. So because we don't have this, people are trying to put things that shouldn't be in that abstraction, that like in that step of abstraction, in that level of abstraction in it, because they have no other places to put that thing. And actually, what happens is you have companies that come in and they take a tiny slice of what a framework should be and they try to like sell it to other people or like put a token over it. Like the gas station network shouldn't be a thing that it's on its own and that people are trying to get everybody to use. It should just be part of a bigger framework. And so what do we do, right? So unsurprisingly, if you know me, I claim that this thing we've been collectively building together that was first described as an engine for autonomous world is actually just like an engine for everything on chain. And it started as something for video games, and it's actually what happens every time. You discover that it's way more general than it actually is. You can take pictures. So I claim MUD is the missing Ethereum framework, and it's our last hope for a proper application stack.
Okay, let's stop here. I just wanted to play that. Yeah, Justin is a great presenter, and yeah, this is kind of like the MUD approach, or at least the value proposition from a high level. And I thought it was interesting also how he mentioned he made the parallels to like the RISC-V VM and stuff like that. And yeah, I think it's good food for thought for the conversation maybe in a bit. To go to the next slide, this is kind of some of the features they have now. All of this is, I recommend actually watching the MUD video. I will link it later on, but you can find it on their YouTube. The whole video is quite interesting. From a high level perspective, these are some of the features that they have. General purpose indexers, account abstraction, a development dashboard, an expressive query language, all of this trying to make it easier for you to build, on-chain games. Again, this uses ECS as well, the entity component system we mentioned. And yeah, just to highlight this picture, I think was interesting. So MUD being kind of the missing framework. And maybe if one of the questions that we could ask is like, what kind of framework that is compatible with RISC-V, because we can actually leverage a lot of these existing things on Cartesi, might be a good fit for on-chain games. To continue a bit, Curio is, they have this custom OP stack chain, they claim massively parallelized ECS built into the chain, high frequency game tick with complex logic, custom stateful precompiles, a built-in networking layer, and is EVM compatible. So they released a few more updates recently. You can check out that as well on Twitter if it's interesting. And finally, we have Argus Labs, they just released this last week. They call it the World Engine. Again, you have a tick-based runtime. They have stuff like native account abstraction, ECS, entity component system runtime. And if you look at kind of their designs, again, like this is me sort of sharing some of the information. Would probably, the more accurate way to kind of dive into this would be to watch the video or look at the slides. They have this EVM base shard approach and different game shards on top of it. Carlo, curious if you have any thoughts here to share as well. I know we went over this a bit recently.
Yeah, so as Ronan mentioned, there's a lot of things you have to struggle when you do a blockchain game. Indexing data is a classic one for all the applications. And in the case of games, also the dynamics of the games are dictated by the restrictions of the blockchain. So you want to have a real-time game or something like that. It's not really feasible currently because the blockchain has all these guarantees of security, decentralization, and nice things, but that comes at the price of being slow, right? You cannot have a FPS game or something like that because FPS games, they have at least 30 frames per second or something to be playable, which means you have at least 30 ticks per second for game simulation. And those take into account player inputs, right? But you cannot have that if a player input takes 13 seconds to arrive, which is the case on Ethereum. So on the games that people have been experimenting on, this word engine that you mentioned that started, it's one of the creators is from the Autonomous Words Classic, which is Dark Forest. And he's kind of trying to tackle this latency problem, right? So he's saying, hey, we need to have more frequent ticks to have more meaningful games, real-time games, this kind of stuff. So I have a ton of questions about their approach, especially on security, decentralization, stuff like that. But what they're doing is, okay, let's use this EVM-based shard just for slow stuff. So I want to exchange an asset with you, this kind of stuff. They generally don't happen all the time. They don't need to be real time. So we can still use Ethereum or some slow blockchain for that. But if we want to have a highly interactive game, then we need these ticks to be frequent. We need the player inputs to be frequent. So what they do is they do this game shard, which, from my understanding, is a game-specific blockchain. And on this game-specific blockchain, you have high-frequency block generation. So they talk about like 20 blocks per second. And besides that, what they do is they modify this blockchain node. I think they're GAF-based. And they modify it in a way that you write backend code in Go, and it runs within the node. So instead of having a general purpose blockchain in which you have an EVM, and everyone can write smart contracts within that with thousands of nodes having breaking consensus, so it's really secure and robust. They throw away that security for speed. They have a couple of nodes running this high-frequency blockchain generation, and the backend code of your application runs within the nodes. From what I've seen, the way they reach this high speed is they have the sequencers that, again, centralized stuff, so at decrease decentralization, there are different security assumptions. But it's an interesting approach because they're trying to break this cage of expressibility you got on Solidity and also computational power. And on the other hand, also break the communication limitations you currently have on on-chain games. So with Cartesi, for a while, I've been wanting to have something that can tap into this communication problem. So we have a lot of computation, a lot of expressibility that you can have within Cartesi because you can use whatever language you want, and most libraries that have been developed, they can be ported to RISC-V Linux. But we still have this gap on the communication side. So if you have to go through the blockchain, it's really slow. And that limits you to turn-based games or something that's not real time, right? We thought for a while of using something like state channels to make games more interactive. But then there's still the issue when someone tries to cheat or they stop cooperating. If you have a real-time game like Counter-Strike or a real-time strategy game, and someone breaks the cooperation, it's not feasible to play Counter-Strike going back to the blockchain, right? Once again, you need like 30 ticks per second or something like that for it to be playable. And if you fall back to the blockchain, you're constrained to the throughput that the blockchain gives you, which is on Ethereum is roughly one action per 13 seconds. So it's really cool seeing how the industry is evolving and it's trying to break away from those limitations, right? Because everyone wants real-time games, and solutions are being proposed to make it possible in a decentralized fashion, or at least in a more decentralized fashion. I'm not sure if Milton has any thoughts about it, or Ronan.
It's interesting, like you say, like it's like sacrificing like decentralization to offer like new game, like different kind of game. I personally still keen to explore the other side, which is game that are slow, but because of the value inside and the mechanism of being permissionless. So yeah, I mean, I still think it's interesting, like to see, like, you know, all the technology going in different direction, and yeah. But personally, I still keen to see different game design rather than trying to put Counter-Strike on chain, even if it would be cool. I mean, because there is also the issue, I guess, is it's like when you remove decentralization a bit, the way I see it is that decentralization, it's almost binary, because as long as you don't have it fully, then someone can make use of that power. And the main issue for on-chain game is like, I mean, it depends on the kind of game, of course, but for a multiplayer game like this, like you basically want to ensure that the ordering of transaction is not manipulated. It cannot be manipulated. And all of these solutions that kind of remove throughput, etc., remove that. Basically, someone has control of the ordering. And this can be the things that make you win or lose the game. And so it becomes trusted game, which is fine. In some way, it's, like you say, it's better because you maybe you have transparency at least, except the ordering. But so I agree with you that it's interesting to see the different thing, and it's kind of why the same thing that make me start on building Eternal back then, when there was XDAI and Polygon, which were like not as decentralized as they could be, and it was still something, oh cool, now we can make this kind of game. And so I still think it's interesting.
Yeah, the whole problem is how do you keep the decentralization security but increase the interaction and lower the latency, right?
Yeah.
So in If Denver, we saw there were a couple of groups in consensus trying to do this through state channels or similar stuff. So Lina and Barros went into a presentation about this, and they met a guy that had a different approach. So he was creating what he called battle rollups. So the idea was that you reach consensus among the players, and you kept going through the game state through that local consensus. And if someone tried to make a transition on the game that was not valid, then you would actually go back to the general line chain and show that that person is trying to make an invalid state transition and lost the match.
Okay.
But again, relies on local consensus, right? So collusion is a possibility, right?
Yeah, okay, I see. Another thing I think that will be interesting to look at now, and is because of 4844 on Ethereum. Yeah, I mean, it could even be maybe another, like it's the direction it's going. You could even extend this to maybe another type of transaction which store really ephemeral data, like 4844. I think it's like 30 days. They have to keep for 30 days the data, so that allow like rollups, you know, to prove basically something is valid with this data. But you could imagine something, and actually the team, I guess you know the team of Xayah, they were working, they had a paper on this kind of solution. They were calling them game channel, and I'm not sure now because I read it that a while ago, but it might be similar to what could be another 4844, where instead of storing the data for 30 days, it could be storing the data for 3 seconds or like 20 seconds. I mean, it won't get to the throughput for, FPS game, but and the idea is that the nodes will only need, they will accept that data, sign it, be part of the block somehow, but it will not be needed to be kept. And so you could maybe, so it's similar to 4844. Actually, 4844 can be used for that, but we could maybe even go further down while keeping decentralization.
Yeah, the problem, as you said, it's one is sequencing, and the other one is, okay, so when something goes bad, how do we keep the game playable, right? Because when you're on like 20 ticks per second, you don't really have room for disputes, right? That breaks the game flow.
But I mean, technically, it depends on the game. But technically, I think only the ordering matter, because if there is, I mean, if the rules are designed somewhere, then if it's invalid, it's invalid, right? So I mean, I guess you are talking in the case of state channel, which the idea is that the thing run outside of the chain. But if every action is on the chain using something like 4844, then the invalid case doesn't matter, because it will not be taken into consideration.
Yeah, it's a trade-off of how complex you do your game, the time you want players to interact, and what happens if someone cheats, right? Because depending on how you design the game, you can put the cheating part on the lore or in the game mechanics. Imagine a game that's based on optimistic rollups. You can make that when there's a dispute, it can be part of the lore of the game. What's happening on the dispute?
Yeah.
Like there's a thunderstorm and now you can't move, so you have to lay low, stand still, replenish mana or whatever, depending on the game, right?
Yeah. That's for Eternal. We had that for we were using we were not using the previous block hash. We were using the block hash of the transaction, and the contract don't have access to it. And so what happened is that the contract was waiting for a next transaction to come to record the block hash. But the client knew the block hash from the get-go. But the issue is that what if nobody make a transaction? Ethereum keep 255 block. What if nobody? We had a bot that was injecting a transaction just to make sure. But if it doesn't happen, it means the block hash will change. And so it means in the UI, we were showing something magical where the room, because every room was generated based on the block hash, was will change. And so you have to think about this stuff definitely for a game. But I think it's interesting also throughput, because throughput, there is also a component, it's almost the same component, it's the gas cost. Because at the end of the day, currently the game I'm looking at, which are more don't need high throughput, but need low gas. And usually if you have high throughput, basically you have low gas per this transaction, because otherwise you have your high throughput, you kind of go out. But it also means actually the other problem with high throughput is that everything need to scale with it, and so it means your indexing need to scale with it, and so you are sacrificing also decentralization in that aspect, because it means everything. So for example, my indexer in the browser, if I have to index everything that's happening, then suddenly it becomes far harder to keep up. Of course, it depends on the game. Some games are kind of a state that doesn't grow; it just update but doesn't grow. So it kind of depends, but. Also, the throughput thing is up to when, because you need to scale with the number of players, right? And so you either keep the throughput but increase the gas, at which point, okay, fine, it's high throughput but nobody can play, or you reduce throughput, and then you I don't know. It's a tricky one, I guess. I don't know how we will play out. Basically, is what I mean.
Yeah, on this word engine, they're kind of going to our approach, right? Which is, okay, a single machine doesn't scale, so let's make different machines for each game. So they actually have, it's what OPCraft did, right? It's a specific chain. It's a specific chain for the application.
Yeah, but what if the game? Because like we mentioned, like collision is an issue. Like you can't really design a game that is permissionless and have a limited number of players. And so, or even if the limited number of players, what if someone DDoS the shard just to get an advantage in the game? Because that's a problem of cheap thing, cheap and high throughput.
Yeah,
it introduces new issues, new issues.
And that's what holds us back on this latency stuff, because the way attack works is you can always go back to Ethereum to prove someone did something nasty. But for that, you need everything to be available on chain, right? And when you try to go to lower latency and this kind of stuff, you have to remove the inputs from the base layer. And then there's this issue.
Yeah.
I'm still trying to figure if the industry comes with, or even us, with a clever solution to this problem. We need some way of communicating faster, but that can still be backed by a base layer like Ethereum or something in case of disputes. So you can blame people, so people cannot DDoS or do anything like that, or collusion, and get away with it, right?
Yeah.
Gotcha. Any thoughts on this?
Yeah, blockchain. I'm curious about your thoughts as well, Milton. Feel free to also jump.
Like, how far could just good UI and good like client-side prediction get us to, tricking users into thinking that our Web3 apps are real-time?
I think if there are no disputes, a long way, but the problem is if there are disputes, then that prediction breaks completely, right? And you have to either halt the game or go back for a long bit. And for the older guys like me that had issues with internet on real-time games and stuff like this, it's not cool when you get teleported on an FPS or stuff like that.
Do you think that, you mentioned it, but disputes and rolling back, that might just be like an unavoidable issue that the users will have to pay for?
Might be. I don't know if we can design games that put it into the lore. Kind of like that Tom Cruise movie in which he dies and goes back and dies and goes back. Might be that we design some cool games that has this thing embedded, so when it happens, it doesn't break the experience. But good enough prediction that it won't break the usage.
Yeah, I think if the UI is good enough, then users will be okay with it, because in Web 2, people already deal with rollback in a lot of high throughput fighting games.
Yeah, I think obviously you were talking about rollback in fighting games. I think that's pretty common. And I think for at least for turn-based games, it could seem the UI can make things seem really seamless already. For real-time games, I think you've kind of nailed it on the head on that. I think having rollback or disputes breaking the experience, I think that's kind of a big given, that if there are real disputes, it's understandable that something needs to be done. And the user will know that probably one of the users has done something malicious, and it's going to break the experience anyways.
Yeah, I completely agree with that. I think that the issue is not even that. I think that people get used to the fact that sometimes if something malicious happens, then things will stop, right? People will verify, and it's normal. Even in the normal world, right, the Web 2 world, this can happen. Okay, let's halt the exchange or whatever because there's something critical going on. I think the issue is really to make sure that you can communicate fastly. I mean, for that kind of game, I like what Ronan said. Decentralization is binary, so either you have it or you're not, or you don't. And when you try, and I also like it, the idea that maybe you should explore more what can be done right now and other game designs. But for these really highly interactive games, the issue is really being able to identify when something malicious happens. And so at some point that maybe has to be verifiable afterwards. And as far as we know, there's not a good solution that you can have like instant communication, but still have that ordering and everything that happened exactly the way it happened, like verifiable, right? Replayable and verifiable somewhere. So at present, you have to put the data on chain, at least the input data, right? So that can be played back afterwards. And that's the issue that we get mostly. So there are these state channels approaches, but in the end, at the point at least that we know, it's still not possible to blame it on the misbehavior, on the party that's misbehaving, and that breaks the real thing. So that's the issue that we still have to solve, in my opinion.
Yeah, but in the end, the industry has different approaches, right? We have using a base layer like Ethereum, super safe, super slow. We have state channels on the other side, which is very unreliable but super fast. And now we're getting these application-specific chains with higher throughput, but probably decreasing a lot the security level and decentralization.
Yeah, we don't want that, right? We want it to be secure, right?
Yeah. Max, anything else on the agenda?
No, nothing else. This is just last few minutes for conversation, but I think this has been quite interesting already. Curious, maybe blockchain. You mentioned you've tried mud or some parts of mud you kind of liked. Could you just maybe share that again?
The front end state synchronization. I just like how easy it was to synchronize your client state to the contract state.
Nice. Okay. Was that? If anyone else has questions or thoughts, please share. We might also do in the future sort of like a design thinking workshop. If anyone is interested, specifically about this topic, please reach out. And yeah, I mean, it's been great. Thanks so much, Ronan, for joining. You're always welcome. Please keep on coming to these calls if you have time.
Yes, it was a pleasure. Thank you.
Yeah, thanks. And everyone check out Ronan's games and projects. He's doing some cool stuff. Thanks everyone for joining. Thanks to the presenters. And yeah, let's keep the ball rolling. Excited to see what everyone builds. Thanks everyone.
Bye guys, have a great weekend, and thanks for being here.
See ya. Bye.